Hello and welcome to the course of Computer Networks. In this video, we are going to learn about the Internet, its history, and some components which actually make the Internet. Here is a brief roadmap about today's lecture. First, we are going to learn the outcomes for this lecture, what we expect to learn at the end of this lecture. Then we are going to see a formal introduction of the Internet and the components which include the network edge and the core network itself, and finally the history of the Internet as well as the networking. So first thing is the outcomes. At the end of this lecture, you would be able to learn the basic concept of Internet and present an overview of the edge and core part of the computer network or Internet. And at the end, you will also learn and understand a brief history of computer networks and Internet. So starting with the introduction of the Internet. Actually, the Internet is a specific type of computer network. We have other types of computer networks available. For example, we have local area network, wide area network, metropolitan area network, and personal area network, just to mention a few. Don't worry, you will learn about all these types of networks in the coming lectures. So it is basically a specific type of computer network. You can also say that Internet is actually a network of different networks, or it is the largest network which is available in the world. Why it is the largest network? Because it is composed of thousands of hundreds of interconnected different networks throughout the world. So the Internet is actually, or it is basically, a computer network, a specific type of computer network, the largest computer network, and it actually interconnect billions of computing devices throughout the world. And why we are actually studying the Internet in the course of computer networks? Because its understanding will help us to know the basics of computer network, because itself it is a computer network. And why we are studying? Because today almost half of the world's population, they are actually using some sort of mobile devices in order to access Internet. And according to a statistic provided by Statista 2019, that the number of active mobile users will be increasing by 75% at the end of 2025. So now I have a question. What do you think? What are the different things that are actually connected or that will be connected in the near future to the Internet? As I just mentioned, that millions, billions of computing devices are connected throughout the world with the Internet. So what are those things that are actually connected or will be connected? So if you think about this question, you will come to the conclusion that the first thing that we connect to the Internet is our mobile devices, our computers. Computer means our personal computer, mainframe computer, supercomputer, clients, server, laptop, desktops, and things like that. We also connect our smartphones, our tablets, our watches, and also networking devices like routers, hubs, and other gadgets, electronic gadgets, appliances like refrigerator, like thermostat, like microwave oven, and also our home security systems are connected with the Internet. And in the near future, we are going to connect glasses, watches. They are already connected with the Internet, but we will also be connecting them in the near future, and vehicles, etc. So there are going to be billions of devices connected with the Internet in the near future. Okay, so the second question is actually like we are going to connect billions of computing devices. Now let's see the nuts and bolts of the Internet, or you can say the basic components of the Internet that actually lead to the creation of the Internet. So the first thing Here is the host, which is also known as end devices. The internet is actually a computer network that interconnects billions of computing devices throughout the world. Now, what is a device, or what is the host that can actually be connected to the internet? Well, as I just mentioned in the previous slide, these devices are going to be your desktop computer, personal computer, your laptops, your workstations, your servers, your smartphones, tablets, TVs, gaming console, your home security system, home appliances, your watches, glasses, cars, traffic control system, and many other things. So all of these devices are actually known as host, or sometimes they refer to as end systems. And by some estimates, I think it is from Cisco, and the estimate says that about 18 billion devices are connected with the internet in 2017, and the number will reach to 29 billion by 2022. So the first piece that actually make the internet is the host or end devices, and you can see different end devices here: smart car, smartphones, traffic control system, your laptops, things like that. Here you can see the thermostat, the refrigerator, and the laptops, etc. So all these are examples of the end devices which are known as host or end systems. Beside, we have communication links. End systems are connected together by a network of communication links, and also packet switches. These two components are actually important for communication, for sending packets from one end system to the other end system. And there are many different types of communication links available. For example, if we talk about the physical communication links, then coaxial cable, copper wire cable, fiber optics are available. Similarly, we do have wireless communication links like 3G, 4G. The radio spectrum itself is a type of wireless communication links. So different links can transmit data at different rates, different speeds, and things like that. So communication links are important for sending your messages, your packets from one end system toward another end system. And we do have the packet switches. A packet switch takes a packet which actually arrives at one of its incoming communication link and forward that packet on one of its outgoing communication link. It means that a packet has input interfaces as well as output interfaces. On the input interface, it will receive packets, while on the output interface, it will actually send out the packet toward the destination. And actually there are different types of packet switches available, but regarding the internet, we can divide them into two types. The first type is known as a link layer switch, while the second type is known as router. Don't worry about these devices, as we are going to cover them in this course, but for now, both type of switches forward packets towards their ultimate destinations. And then we have the ISP, which actually stands for Internet Service Provider. And there are a hierarchy of ISPs available. For example, you may be using residential ISPs. For example, it could be your local cable provider, any telephone company, or maybe it is a corporate ISP, or maybe within a university it is a university ISP, and even the Wi-Fi access that is provided to us in different hotels, coffee shops, airports, and other public places, or even your cellular data ISPs, which actually provide mobile access to our smartphones and other devices by using 3G, 4G, and 5G connections. So each ISP itself, as you can see here, we can have the local ISP, we can have a national or global ISP. They are also connected with one another. So each ISP itself, you can see it is like a network. And this network is actually consisting of different packet switches and communication links. As you can see, different routers and communication links here. So the internet is all about connecting end systems to each other, so that ISP that provide accesses to end system must also be interconnected. And the final component here is protocol. End systems, these end systems, packet switches, whether it is link layer switch or router, and other pieces of the internet, they actually runs different protocols, and these protocols control the sending and receiving of information within this internet. You must have heard about the term TCP/IP. What are those? They are actually protocols, the two most important protocols in the internet. Okay, so don't worry about the protocol, as we are going to learn about this in our next video. We will study the protocol in details, but for now it is actually the main thing which enable communication between the end systems, and they are running everywhere in the internet. Coming to the network edge, the first question arises to our mind is why these devices are called the end systems. As we just studied in the slide, that we have host or end devices or end systems. So why they are called end systems? Because they sit at the edge of the network of the internet. So we have this whole internet here, and these are the edges. One edge and the second edge, another edge. So you can see these devices actually sit at the edge of the internet. That is why they are called the end system. So the computers and other devices that are actually connected to the internet are referred to as end system or end devices. And why they are called end devices or end system? Because they sit at the edges of the internet. So you can see in this figure, the internet end systems, they actually include desktop computers. As you can see here, it include different servers. It include different servers like web server, email server, database server, security server, etc. It even include mobile devices, your smartphones, laptops, different tablets, etc. So it could be anything connected. And if we talk about the Internet of Things, so different things could be connected to the internet, like your smart bulbs, your air conditioner, your microwave, your doors if they are smart enough, your windows, everything can be connected with the internet by using the Internet of Things philosophy. So the internet end systems could be anything. An end system, remember, they are also known as host. Sometimes we refer to them as host. Why they are called host? Because they host, or you can say they run application programs. What are application program? For example, web browser program, a web server, an email client program, or an email server program. All these are different application programs that are actually running on the host. So host are sometime end system are sometime called the host, and host can be divided into two things. One is the client and the other one is server. So here you can see a client is actually communicating to a server. Client at one edge of the network of the internet is actually connected and communicating with another device or edge at the other edge of the network. We talk about communication links. For that we have to understand the access networks. Well, this is a huge topic. We will just give a touch to it here. Access network, the networks that physically connects an end system to the first router. You can see the blue lines here. Okay, so actually the network that will physically connect an end system to the first router. And for that we have a path from the end system to any other end system. Here in this figure, you can see several types of access networks. This is an access network. This is another access network. This is another access network, enterprise, content provider network, etc. So we have different access networks here. These thick lines and the colors line, they actually shows the different access networks. For example, you can see here in the home network, we have an access network. Okay, you see we have an access point here, Wi-Fi device here. So normally for home access, we either use DSL or cable modem or cable internet, or maybe fiber to home. In Pakistan, we have many different providers that actually provide you a fiber to the home. And then we also have dial-up connection, the telephone network, and satellite communication is also possible for providing home access or accessing the internet. For enterprises like small companies like universities, etc., and even inside the home, sometime we can use Ethernet, and Wi-Fi is very common. And for wider area, we have to use other access technologies like 3G, like LTE, LTE-A, 4G, 5G, 6G now, etc. So access network actually provide a physical connectivity for an end system to the first router. Okay, and then we have the core side of the network, the backbone of the internet, and this is actually a mesh. You can see the thick lines and the colored line, they actually represent the core of this internet, the backbone of this internet, and it is actually a mesh, a collection of packet switches. You can see packet switches. In this case, these packet switches are routers. So different routers that are actually interconnected, or they actually interconnects the network, the internet and systems. So it highlights the network core actually. And one of the main concept related with this network core is the packet switching. In a network, application and systems actually exchange messages with each other. To send a message from a source and system, for example, this is our source, this is our destination. To end a message, a packet from this source toward this destination, the source breaks longer messages into smaller chunks of data, and those smaller chunks of data are actually known as packets in the network terminologies. So between source and destination, each packet actually travels by using a path. Okay, so to send a message from a source and system to a destination and system, the source will break longer messages into smaller chunks of data, and those chunks of data are known as packets. And between source and destination, each packet travels or goes through communication links, and those link passes through different switches and different routers. Here you can see different routers, and here we have a switch, okay, in order to reach to the destination. So what is packet switching network, how it is different from circuit switch network, we will see in the details in the upcoming videos. And finally, the network core. At the network core, the switches actually uses a technique which is known as store and forward technique, and that is the common of packet switching network, store and forward transmission. We will not go into the details, but at the abstract level, most packet switches, whether it is a router or whether it is a switch, they will use the store and forward transmission at the inputs to the links. What is store and forward mechanism? Actually, it means that the packet switch must receive the entire packet before it can begin to transmit first bit of the packet onto the outbound link. This is input link, this is outgoing link. So first this router need to receive all the packets, the entire packet you can see, before it can begin to transmit the first bit on the output link. Okay, so only after this router has received all of the packet's bits, then it can begin to transmit, or you can say forward the packet onto the outbound link. But the question is how actually things happen inside this router. So to answer that question, we need to go forward, and the answer is by using different forwarding tables, or sometimes people call them routing tables, and that is the responsibility of the routing protocols. Okay, so again the question is like this: how does the router, these are different routers, how does the router determine which link, outgoing link, it should use to forward the packet? For example, this router receive a packet. Now it has three output interfaces, whether it need to forward the packet on interface 1 or on interface 2 or on interface 3. That is a decision that need to be made by this router. In the internet, every end system has a unique IP address, a unique identification, a unique number, you can say. When a source end system wants to send a packet to a destination end system, the source includes the destination IP address in the packet header. When a packet arrives at a router in the network, the router examines a portion of the packet destination address and forward the packet to an adjacent router. For example, this is the adjacent router. So how it knows? By inspecting the field of the packet. By inspecting the IP address of the destination, it decides whether I need to forward the packet on interface 1, 2 or 3. More specifically, each router has a forwarding table, and this forwarding table actually maps destination addresses to the router's outbound or outgoing links. So now you can answer the question: when a packet arrives at a router, the router examines the address and searches its forwarding table using this destination address to find the appropriate outbound link for sending the packet or for forwarding the packet. And the router then directs the packet to this outbound link. Now another question is, how do forwarding table get set? How they are created? Are they configured manually by hand by the network administrator in each and every router? Or does the internet use a more automated procedure for building these forwarding tables? So the simple answer to this question is that internet has a number of special routing protocols. Okay, so that is the answer. Routing protocols that are used to automatically set these forwarding tables. So a routing protocol may, for example, determine the shortest path. Okay, there is one property, that the shortest path from each router to each destination, and then use the shortest path results to configure the forwarding tables in each router. So this is actually a long discussion. We will have to give a touch to them, the routing protocols and forwarding table, in our upcoming lectures. Now this was about the internet and some component pieces, nuts and bolts that actually make the internet. Now let's see the historical perception of the internet. History of any topic for me is a bit boring, but the internet history is quite interesting, because the internet is not really a network at all, but actually it is a vast collection of different networks that use certain common protocols and provide certain common services. Actually, the internet is an unusual system. It was not planned by anyone, as we will see, and is even not controlled by anyone. So here is a brief overview of the historical periods of the networking and internet. We are going through the packet switch networks 61 to 72. We have proprietary networks 72 to 80s, and then we have the big change in the society, 80s and 90s, and then the explosion in the 90s and the new millennium. So let's see them one by one. The first is the development of packet switch network, and that is actually the early history, you can say, of the internet. Well, the history of computer networks and also today's internet, it actually bakes to the early 1960s. And at that time, the telephone network was the world dominant communication network. Not only the telephone network, but people at those time were also using telegraph for encoded messages before 1960s. So in parallel to the telephone network, we had the telegram services, or you can say for voice we have telephone network, while for messages, encoded messages, people were using telegraph. Now, given the increasing importance of computers in the early 1960s, it was perhaps natural to consider how to hook computers together so that they could be shared among geographically distributed network. That was the goal, to link them in order to share information among the user that are actually distributed geographically. Three research groups around the world, they were actually working on this problem. However, they were unaware of the other works. Three groups. The first group was from MIT, and that was Leonard at MIT in 1961. He was trying to give a way to connect computers to one another. Beside from Leonard, two other researchers, there is Paul Barron at the Rand Institute and Donald Davis at the National Physical Laboratory in England. They were also doing they were also proposing solutions to the same problem. So they published some papers about packet switched network. So this is actually from where the development of packet switch network started. Three different groups at three different institutions, unaware of unaware of each other, work trying to solve the same problem, connect computers with one another that are actually distributed geographically. Well, if you are a computer network student, you must have to aware from about the efforts made by the AlphaNet. AlphaNet actually stands for Advanced Research Project Agency, and Net stand for networks. Two words, Alpha and Net. Net for network, Alpha for Advanced Research Projects Agency. In the mid of 1960s, mainframe computers in research organizations were used, and they were standalone devices, no connections between them. Well, computers from different manufacturers were unable to communicate with one another. There were no concept of networks. So the Advanced Research Projects Agency, which is actually that was actually in the Department of Defense, they were interested in finding a way to connect computers so that researchers they funded could share their findings. And to solve the problem to connect the different computers, in 1967 the ALPHA actually present its idea in the form of AlphaNet to ACM. Okay, they actually present the idea of connecting the computer and making a small network of connected computer, to put it in simple words. The idea was that each host computer, not necessarily from the same manufacturer, would be attached to a specialized computer, and that specialized computer at that time they called it IMP, which stands for Interface Message Processor. And this IMP in turn would be connected to each others, that would be connected to another IMP. So if they are connected with one another, the systems connected to them would be able to communicate. That was the basic idea of the AlphaNet, which they present in 1967 to the ACM. And by 1969, AlphaNet and the idea was turned into a reality. It was quite simple network, made from 4 computers, or you can say 4 nodes. One at the University of uh, California at Los Angeles, UCLA. The University of California ends at Santa Barbara, UCSB, the second node. The third one was SRI, the Stanford Research Institute, and the fourth one was University of Utah, UTH. They were connected by using this IMP concept to form a network of 4 nodes. And the software, which they call the NCP, which stand for Network Control, P for Protocol, it actually provide communication. As we will see in the upcoming video, protocol actually provide a means for communication. So in order for these 4 nodes to communicate with one another, they need a protocol, and that protocol was NCP, which is called the Network Control Protocol. So this, you can say, this is like the world first network, which is made from 4 computer or 4 nodes, and it was actually the efforts of the AlphaNet project. And then after that we have the second period, which is like the proprietary networks and internetworking, and this is like 1970s to 1980s, because in the early years of the 1970s, or you can say from 1970 to 1975, additional standalone packet switching networks, beside from the efforts of the AlphaNet, they came into being. It was the time for developing more systems or more architecture for connecting the networks, and it leads to different systems. So the number of networks was growing in this period, and you can see some of the examples mentioned here. For example, AlphaNet, it was a microwave network, which actually the effort was to link universities on the Hawaii Islands. So that was like a network for linking universities. And then we have another project that is the Telenet, which was a PPN commercial packet switching network. And then we have the Cyclades time sharing networks like TimeNet and GE Information Services Network. From the IBM we have SNA, which was a parallel effort alongside the AlphaNet. So the number of network was growing in this period. And then something important happened. You can say the birth of the internet starting with this era. Okay, this is actually these are actually 2 well-known personalities, Vint Cerf and Bob Kahn. Both of them, they were actually part of the AlphaNet project. They actually collaborated with one another on what they called the interneting project. They are actually the pioneers of the internet. They wanted to link dissimilar networks. Remember, the concept of the internet is a network of networks. So they were actually trying to link those different dissimilar networks together. Why? Because they want a host on one network to communicate with the host on another network, the basic idea of the internet. However, there were other problems to overcome. For example, if you are trying to connect dissimilar networks, then there are going to be dissimilar packet sizes, diverse interfaces, diverse transmission rates, and other requirement parameters. So that was a challenging task. So Kahn and Windsurf, they devised the idea of an intermediate device which they call the gateway, which is going to behave as an intermediate hardware to transfer data from one network to another network. And for that, the concept of TCP was emerged. When Cerf and Kahn, they published a paper, a landmark paper in 1973. And there they outline the protocols to achieve end-to-end delivery of data, or in other words you can say to send a packet from one network to another dissimilar network. This paper on the TCP, transmission control protocol, which is an important protocol and playing an important role in the internet today. It actually includes the concept of encapsulation, datagrams, and the functions of the gateway that they define. This alpha-based internet now become the focus of the communication efforts. This TCP become the backbone of today's internet as well. So in October 1977, an internet consisting of 3 different networks like the AlphaNet, the packet radio, and the packet satellite, they were successfully demonstrated. Means they were able to successfully connect 3 different networks by using this protocol, and not only connect them but also communication between these networks was now possible. And shortly after that, authorities made a decision to split this TCP protocol into 2 protocols, or you can say the inclusion of the IP protocol as well. So IP would handle the datagram routing, as we will learn in the upcoming lectures, and TCP would be responsible for high level function like segmentation, reassembly, error detection, etc. Then we have the next period, and that is the proliferation of networks in between 1980s and 1990s. So by the end of 1970s, approximately very limited number like 200 hosts were connected to the AlphaNet network. But see what happened after 10 years at the end of 1980s. The number of hosts connected to the public network, they actually reaches to thousands. So you can say that 1980s were actually a time of tremendous growth in the host connected to the network, and much of that growth resulted from several distinct efforts to create computer networks linking universities together and by providing other means of communication. So in 1981, under a Defense Department contract, UC Berkeley, they actually modified an operating system that was based on Unix to include TCP/IP. You can say that TCP/IP was actually included in the Unix operating system, and Unix is an open source. So the open implementation of the Unix gave every manufacturer a working code base on which they could actually build their product, and the idea was successful. In 1983, the authorities finally abolished the original AlphaNet protocol, and the TCP became the official protocol for communicating or for linking different networks. And then after that, the concept of DNS was introduced, and DNS, domain name server or system, that is used to map between a human readable internet address or name and its 32-bit IP address. That is something which is not relevant at this stage. We will study DNS in upcoming videos of this course, but for now there is actually a system which translates IP address into a name. For example, you write www.google.com in the web browser and it is translated into an IP address, unique IP address, and that is done by the DNS. Beside from DNS, there were also some improvement, like in the IP addresses, they become more common in order to uniquely identify different hosts. Well, the period of 1990s is something which is dedicated to one man, and that is known as the Tim Berners-Lee. and he's the father of the World Wide Web, WWW in short. So this is actually the era in which a large number of events lead to the commercialization of the internet. And the main event was the World Wide Web application, which brought the internet into the homes. Now you can access internet not only from universities, research institution, but also from your home, from your businesses. And not only 100 or 1000 machines were connected to the internet, but now millions of people worldwide, they were able to access the internet by using World Wide Web. So the web served as a platform for enabling and deploying hundreds of new applications. Okay, and there is actually what we are using, what we are seeing today. For example, today we have the Google, the Bing for search engines. For internet commerce, we have Amazon, eBay, and for social networks, we have Facebook, Twitter, etc. So all these are examples of the web, and that was actually invented by Tim Berners-Lee between 1989 and 1991. Actually, the Tim Berners-Lee and his team, they developed initial versions of HTML, which is still used for World Wide Web, or you can say website development. HTTP, which is a common protocol still used today, a web server, and a browser. So these are the four components that actually leads to the creation of the World Wide Web. HTML, which is a language, HTTP, a protocol, a web server, and a browser that you need to access the services offered by these servers. So around the end of 1993, there were about 200 web servers in operation. This collection of servers began just of what was about to come. And at about this time, several researchers were developing web browsers that actually support graphical user interface, including the Mark, and also web browser from the Microsoft later on. So by 1995, university students, they were using Netscape browser to serve the web, but later on in 1996 we saw web browsers from Microsoft. They also develop or make browsers, which started the browser war between Netscape and Microsoft. And after few years, Microsoft actually lead the Netscape Navigator, etc. So the second half of 1990s was a period of tremendous growth and innovation for the internet, with a major corporation and thousands of startups creating internet products and services. And you can see like the email services were introduced, web browsing, commerce, e-commerce, instant messaging, peer-to-peer file sharing, and things like that. And then the new millennium after 20,000, or you can say at the beginning of the 21st century. Actually, this is something which changed the perception of the information technology or in the internet. In the first 2 decades of the 21st century, I would say that no other technology has transformed society more than the internet alone. Why? Because this is the time where the smartphones were connected with the internet. You can say that the innovation in computer network continued to grow at a rapid pace at the beginning of this new millennium. Advances were made on all fronts, including like development of faster routers, high transmission speeds in the access networks like 3G, 4G, improvement in the network backbones, etc. Since the beginning of 2000, we have been seeing aggressive development of broadband internet accesses even to homes. Beside from DLS, we have fiber to the home. We have 3G, 4G, 5G available in the home, at the homes, or even at the move. So this high-speed internet access has set the stage for a wealth of video applications like for example YouTube, or on demand streaming of movies and television shows on Netflix, for example. It also opened doors for instant messaging like Skype, FaceTime, Google Hangouts, etc. So the increasing ubiquity of high-speed wireless internet access is not only making it possible to remain constantly connected while on the move, but also enable new location-specific applications. For example, Tinder and Waze, etc. All these are location-based applications. So the number of wireless devices connected to the internet, there is actually increasing at a rapid pace in this new millennium. And besides, we do have some improvement in the online social networks such as Instagram, Facebook, Twitter, WeChat, etc. WeChat is popular in the China. So they are created and they are used by massive people, connecting massive people and building massive people social networks on top of the internet. So many internet users today, they actually broadcast live also on these social networks. They can share their moments with their friends and family. And lastly, the cloud computing platform was also emerged in this new millennium. Many cloud companies, for example Amazon EC2, Microsoft Azure, Alibaba Cloud, etc., they are offering their services to the community. There are different models like public cloud, private cloud, or hybrid cloud, community cloud, etc. So they are offering their services. So this was a brief history of the internet. The question is, what's going to be next between 2021 to 2030? Virtual reality, augmented reality, artificial intelligence, robots, smart vehicles, smart cities, Internet of Things, Internet of Many Things. So all these are the emerging trends in the coming era. This was about today's lecture. Thank you for watching the video. Take care and goodbye.